Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an equation with complex numbers. What kind of equation are we dealing with? I'll tell you a little bit more about it. We have z minus I equals z squared divided by 2i. Now at this point, go ahead and make a guess, but don't tell anyone else, and see if your solution works. Because for these kinds of equations, you can guess and check. But how do you guarantee that there are no other solutions? So we kind of need to talk about what type of equation we have. And let me tell you, we have a quadratic equation because we have z and z squared. There's no z here or anything like that. So we'll cross multiply, right? But again, like I said earlier, because of the presence of 2i, you might be able to guess the solution. And hopefully that solution will lead you to another solution. Anyways, let's get into it. So to solve this problem, we could probably talk about two different methods. One of them is replace z with a plus bi. Okay, if you do that, let's call this first method, you'll get a plus bi minus I, and then I'll cross multiply by 2i, equals z squared, which is a plus bi quantity squared, right? So here we can simplify this by putting together the imaginary parts, and then I'm supposed to multiply this by 2i, and that'll give me a times 2i plus b minus 1 will be multiplied by 2, but then I times I is I squared, don't ever forget that. And also, if you're new to complex numbers, go ahead and check out my lecture videos. I also have another channel where I do problems on algebra and number theory, and hopefully geometry anytime soon. Maybe trigonometry too, once in a while. Anyways, that's cyber math, S, cyber with an S. So I squared is -1, so this will turn the plus sign into a minus sign. Be careful about that. And this equals this. So a squared, b squared, I squared, that's minus b squared plus 2abi similarly. And then from here, we kind of need to compare the real parts and the imaginary parts. Real part here is -2b plus 2, and here it's a squared minus b squared. The imaginary parts are kind of easier to compare, 2ab and 2a. So 2a equals 2ab, and then we can kind of put everything on the same side and then factor, because this equation is a lot easier to solve. Factor out 2a, 1 minus b equals 0. This means that either a is 0 or b is 1. Make sense? If a is 0, then I can kind of think about it, plug it into the other equation. So what I mean by the other equation is this is my system, okay? This is equation number 1, this is equation number 2, and I just used equation number 2 to solve for a and b, and I got a equals 0, that's one of the branches. If a is 0, plug it into the first equation, number 1, you'll get -2b plus 2 equals -b squared, and you put the b squared on the left hand side, you get b squared minus 2b, or not 2b, sorry, I had to say that again, plus 2 equals 0. Guess what? This equation has no real solutions. Wait a minute, isn't this channel all about complex numbers? But a and b have to be real, okay? That's how we define a complex number. When you write a plus bi, a and b are supposed to be real, okay? So we don't get any good b values, which means a cannot be 0. You see, we look at each case, or b equals 1. So b equals 1 has to work. If b is 1, plug it into the first equation, -2b plus 2 is going to be 0. Remember, a is unknown and b is 1. This gives us a squared minus 1 equals 0, which means a squared equals 1, which means a is either 1 or -1. And then based on these values, can we find the b? Well, we already know the b equals 1. So from here, we get the following pairs, which means a is 1, b is 1, a is -1, b is 1. So z is equal to a plus bi, remember? So that means we have two solutions. Houston, we have two solutions, and one of them is a plus bi, which is 1 plus I. The other one is -1 plus I. So that's what I meant by maybe you can guess and check, because if you remember the original problem, I don't remember. What was the original problem? Okay, it was z minus I equals z squared divided by 2i. If you know that 1 plus I squared is 2i, then this problem will probably be easier for you. And of course, if you square negative 1 plus I, you get negative 2i because it's the opposite of 1 minus I. You see what I'm talking about? I hope you do. Let's go ahead and see how we can do it with the second method. I usually like presenting 2 or more methods if possible. And I know some people don't like it. I hope you like it. Let me know what you think. Always feel free to let me know what you think, positive or negative, but I definitely favor the negative comments more, but I still try to respond. And also, anyways, whatever, I forgot what I was going to say. Second method is probably a little easier, maybe, I don't know. Let's go ahead and cross multiply. First, we get z squared equals 2iz minus 2i squared, that is plus 2. Awesome. Let's go ahead and put everything on the same side and then apply the quadratic formula. I'll show you an alternative method, kind of like a 2a and 2b. So I can say the 2b again one more time. But the 2a would look like this. We would use the quadratic formula directly because it exists, right? I mean, you can't use a quintic formula because it doesn't exist. Z equals negative b plus minus the square root of b squared. Careful, if you square negative 2i, you get 4i squared, which is negative 4, minus 4ac, that will be plus 8. Interesting because we get a real number. Plus that and divide by 2. And this will be 4, which is going to give us 2. So it's going to be 2i plus minus 2 divided by 2, which means plus minus 1 plus I, which means 1 plus I or negative 1 plus I. The real part is plus minus. That's why. And I know that I write the plus minus upside down. A lot of people talked about it. This is how I write it. It's like my way or highway, okay? Anyway, so those are the solutions. And so we are very lucky because we found the same solutions. No, because we're solving the same problem. So let's go ahead and talk about the 2b or not 2b. Sorry about that if this joke is kind of like too much. I know some people don't like it, some people like it. Anyways, what is the second method? The second method is completing the square. So we're going to leave the 2 on the right-hand side, and we're going to be adding something to both sides. And that term is going to be determined by this. What's the coefficient of z? 2i. What's half of 2i? 2. I mean I. Okay, and you need to square it. That's what you need to add. So we're supposed to add I squared. And let me just add I squared for now. I know it's negative 1, but the reason why I do that, I want to show you, okay, this is z minus I squared. Makes sense? And this is 2 minus 1, which is 1. Beautiful. From here, you can split up into 2 solutions. Z minus I is 1, or z minus I is negative 1. So z can be 1 plus I, or z can be negative 1 plus I as before. It's just an alternative to the quadratic formula, or maybe this is how they came up with the quadratic formula. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.